Hi, you saw this? And you're here to see this? Awesome, let's go. I'm back in Blender 3.0 and the first thing we want is this circle. So Shift A, Mesh, Circle. I'm gonna take 20 vertices so that we have this kind of thing here. Cool, then we're gonna go to animation nodes. Make a new node tree, like that. And then I'm just gonna set up this simulation thing again, like simulation input, create a simulation output. In the beginning here, we're gonna need a set struct element, plug that in there. And we're gonna need a get struct element. And now in this tutorial, we're actually gonna make use of this struct where you can, like I explained in the last video, plug in multiple things. So in the last video, we only had a list of floats, but this time we're gonna have a list of floats from our sound spectrum, and we're gonna have to track the position of our particles since we are now generating particles, like our own particle system. Very simple for this tutorial, but that's what it is. So we're gonna need that float list again, and we can call it vol. And we're gonna need a vector list, and we call that pos. And here, again, float list, you just have to copy this over, vol, and a vector list called pos. And then once you have that, you can just Shift D that because you have to plug it in here. So this is our loop. How do we start? So what initial data do we start with? Well, we want to start with we could start with nothing, or we start with the circle. So we plug the circle in here. We take the vertex locations into the pos, because that's the vector list. Yeah, that's the circle. And then we have to do two things here. We have to take care of the volume. So again, we're going to need some sound spectrum info. And the sound spectrum always needs the time info. So we plug that in there. Now we need some sound. So let's go to video editing. I'm also going to save this quick. And then I have some music here. And then display waveform, move this over. This is from crispy.zone/music. Awesome music and sound effects for creators. So I love it. Cool. Empty sound. Yeah, we have to pick our sound here. Also, what do we need? We want to set the amplitude to 1, so values between 0 and 1. I know we need 20 because our circle has 20, right? So we are putting the sound spectrum onto the circle, and then we're shooting out our particles. But I think I'm gonna set it to 30 and then take a list slice, like that. And we are gonna set this to length 20. Okay. So this is what we're gonna do with our volume. And this is the data from the frame before. We have to add this together. So we're going to take a list, combine, float. We take the historical volume info, the volume info for the current frame, and we're adding new data on each frame. We're adding 20 new float values to this list. And that's really the awesome thing here. If we take a viewer node, plug it in here, we can see, okay, 20, awesome. And if I hit play, you can see it's rapidly growing. This list is growing. Each frame we're spawning 20 new particles, basically. But at the moment we're just dealing with the sound spectrum that we have. What about the position? So each vertex here on the circle gives us a position, and we get the historical position from the frame before here, and we need a new position. So how do we do that? Well, we have to create a loop, right? We need to move those 20 particles a little bit outwards. And since there are 20 particles, not just one, we need a loop. So let's create a loop, loopy loop. input a vector list, and we create an invoke node, plug that in here, or we will plug that in there, because first we need a vector list output, vector in, vector out, and then this guy can be in here. So that's on that. What do we want to do inside of our loop? We want to move the particle outwards. So if I go into edit mode so we can see the little vertices here, this vertex has a position, and its position is this vector from the origin to its position, right? So if we want to move this outwards, it's very simple, because we can just add that same vector to itself and move it outwards, but maybe not the whole length, maybe just a little shorter, which gives us a speed factor, basically, right? So let me delete this. We are gonna need a vector math node. Vector math, no, not list math, vector math. We want to add to our position vector the position vector, but we want to scale this down a little. So we could do a vector math with a multiply, or we can do a vector normalize, if I can find it. Oh, that's also vector math, right? Vector math, plug that in here, set it to normalize to a length of 1. Okay, so we're gonna change this length a little later. Let's just see if any of this works. So let's plug in a 3D viewer, look at our positions here, dots a little bigger, purple or pink, go back to frame 1, and this is what it looks like. Whee, it's very fast, very fast. Length 0.1. Okay, so we have one circle moving outwards. That's cool, but we wanted to spawn a new circle on each frame. We haven't done that yet, so we're gonna need another combine list. List combine. This time it's a vector list, because we're combining our historical data, the old particles, with a new circle of particles. So we're in this list also we're adding 20 new particles on each frame. And really, what do we want to add here? Well, we want to add those 20 new particles, like a new circle, right? And then we can look at this in the 3D viewer. What do we look like? Yep, looks cool. So we have particles moving outwards. It looks like we're adding particles on the outside, but actually we're adding particles in the inner circle, and then those are moving outwards. Okay, so now we can't see anything yet. We only have this 3D viewer. Let's switch that off. Let's start creating particles. I'm gonna no. I'm gonna go out of edit mode and in object mode, shift a icosphere and set this resolution down to something really small. Move this guy out here. This is what we're gonna instance. So we're gonna need an object instancer. What do we want to instance? The icosphere. How many instances do we want? Well, this is going to be changing now, right? On each frame we have more. So we're just going to take this list, plug it in here, which gives us a get length node. And then we have the correct amount of particle icosphere objects for our simulation. Then we have to place those. And where do we have to place them? And how do we place them? Well, transform output. Those objects need to have a new location, and the location is, well, this list of vectors. Of course, now they're huge, so we have to scale those particles. 0.1, now they're small. Okay. Let's see. Okay. Same thing. Now, how about we scale the particles according to the volume? We have this list of floating point numbers that we could use. So if it's loud, we want the particle to be bigger. Let's do that. We need a vector here. Scale is a vector, so we have to do vector combine. Whoops, that inserted in the wrong noodle here. So combine, we take this combine float list, X, and then Y and Z. That gives us a vector that we can plug in there. And we probably want to multiply this a little bit. So number math multiply gives us a factor. Let's just take 1 for now and see what it looks like. Save, go to frame 1. Okay, one thing we notice here. At the moment, we just keep generating new particles, like they never die. And at some point, we're gonna crash our system because these lists, they just grow and grow. So what we want to do here is to like cap this, to limit this. And it's really easy to do. We just take a list slice, plug that in here. And we always slice at length, maybe 400. And you know what? I'm gonna create a number integer, put that 400 in here and use it here because I need another list slice in here, set to length. Did I set this one to length? Yep. Set to length with that same value. I don't have enough space anymore. So length. So this slicing here is just to make sure that we never have more than 400 particles. For your final render, you can set this to 2000. For the viewport, you might even want to set it down to 200. Okay, but now you have a setting here. Let's go back to frame 1. Play. Something is not right. And I think I know what it is. Since we're plugged in the slice here, we're only keeping the beginning of our list, like the front 200 or whatever. But we're spawning new particles at the end of this list, so we have to switch this around. The new stuff is at the beginning, the historical stuff gets added to the end. Here the new stuff from the sound spectrum is at the beginning, the historical stuff gets added to the end. Let's see if that works. Yes! This looks nice. So now this looks pretty cool, I have to say. Let's set the simulation time to 1000, and we also have to do that in here, end frame for the simulation. Okay. Now, one thing we can do here is they are all moving at the same speed. How about we not only make them bigger for the louder values, we also make them faster. And we can do that down here. This is our loop where we're moving the particles. So we plug our float list into this loop, and we plug that in here to get the speed. Then we plug this float list, the same float list that we have here, the historical one, into here. And then what does that look like? Ah, that looks cool. So they're really loud, like the bass kicks, they move really fast. Maybe a little bit too fast, so number math multiply 0.5. Yeah, this looks cool. Awesome. Now how about colors? They're all just white colors. So this looks like a big mess, but up here we have our objects. Now how do we assign colors? Easiest way to do that is to use a vertex color. So where is this guy here? My root icosphere. Let's go here, let's give it a vertex color slot. It's called col, okay. And then we're gonna need, let's just look for it, set vertex color node. So this object needs a vertex color, but this set vertex color node only works for a single object. So what do we need? A loop. Tiny loop up here. Subprogram, create a loop. We're plugging in an object list. Inside of the loop, we can assign a vertex color. How do we get this color? Well, we said we want them to be like in the last video. Red would be like the loud stuff, green would be the quiet stuff. So we have our volume, where is it? The list for the volume, that would be this here. Actually, we're working with the historical list only, so we're taking this list. This is the float list for the volume that has to be plugged in here. So let's create an invoke node. These are the objects that we want to set the color on, and we need our float list, and we can plug this float list in there as well. So now in here we have each particle object and our volume information. And to make this, turn this into a color, we can go color combine, and we're just gonna set it to R, G, and B. Right, so we're not actually using the color, we're just making like a factor that we can use in a shader. So let's see, shader. Let's go to the shader editor. No, shader editor. Pick this guy. We are going to create a new material. Again, we want a converter color ramp set to HSV. We start with a dark green. We go to a bright red, so we get this color ramp again. And then we need an input vertex color. Here we have this color slot that we just created, which gives us a factor. It's not really a color now, it's a factor. We use that in here. Now they are all green. So let's see. Go back to frame 1. Yep, they're all green. Why are they all green? Float. What are those float numbers here? How about we plug in a viewer? And let's just see what those numbers look like. Okay, so they're very small. Okay. So maybe we just need another number math node in here to multiply this by some factor. Am I doing this right? Float list, float color for the object. Oh, they're all the same color. And the problem here is that the object instancer reuses the mesh data block. And if you want actual, like each particle has to have its own mesh data so that it can have its own vertex color, we have to enable deep copy. And here we go. So let's see. Yeah, multiply by 2 might be good. Okay, so the loud ones are big and red. This is actually pretty slow already. Why is it so slow? I'm not even getting 30 frames per second. Let's see. Yeah, like I said, this limiter here that we put in here for the viewport, you might want to set it down so you have a real-time view. But for the final render, you can turn this up to thousands. Okay, the really tiny ones are really tiny actually. We could fix that, and you know how to fix it. You just have to work with those numbers that you have in here, or the scale here you can take care in here. We have this math multiply by 1 that we're actually not using. We could do, let's try it. So let's plug this back in here. Why isn't this working? So this is that. Okay, and then we can take a map range node, and we know we have values between 0 and 1. We want to map them to values between 0.2. That's actually quite big. 0.1 and 1. Maybe not even 1. 0.8. 0.7. Okay. So we get this. We can turn this down. Okay. Now for the final render, all I did was put a camera right in the center on top and then rotate the camera slowly, because most of the sound is happening in the lower frequencies here. And that looks kind of boring, and by rotating the camera, you just rotate the whole view. Quick recap, because this looks like a big mess. So this is just for the color. Let me plug that over here. This is that loop that we're executing up here for the color. All of this is to instance our icospheres. This loop down here, this is just to move the particles outwards. This is for the sound spectrum, taking care of our floating point list, and this is taking care of our vector list. We're spawning 20 new particles on each frame. We're taking the original circle positions, and we're adding those to our historical positions. Back here, we're just capping so that we never have more than 100 particles in our loop. Now, one final thing, it is all looking very uniform. We could add a little bit of an interesting wiggle down here. So in our loop that is moving the particles, we're just gonna put in a vector wiggle, like that, plug that in there. The amplitude is definitely too high, I would say. What do we need? We need a seed value. We can always, inside of a loop, we can always use the index for the seed so that each particle gets its own random number. Then we need an evolution, and that is just the animation time info. I'm sure you know how the wiggle node works. That's always what you need. You need to give it time info, the amplitude, and what does that look like? It looks kind of cool. It's a bit much. So maybe turn this down to 0.2. But you can see that now they're not just moving out in a straight line, they're kind of wiggling. So let's try and set this to 400. I hope that works. Well, it doesn't match the sound anymore because now the viewport lags behind. The wiggle is still a bit big. 0.1. Okay. The speed we could turn down probably 2. Yeah, this looks interesting. This looks interesting. Cool. So this is our node tree. I hope you can sort of read what it says, because it is a bit messy. If you're a creator and you need amazing free music and sound effects, check out chrisp.zone/music. That's it for this one. I hope I gave you an impression of how powerful these new simulation nodes in Animation Notes can be. If you can come up with something really cool, don't forget to tag me on my socials. If you're interested in more Animation Notes tutorials, I have a whole bunch here on my channel, and of course I will make more in the future, so maybe consider subscribing. Thank you to all of my patrons who really keep me going and make this channel possible. I hope I'll see you in a future tutorial. Thanks for watching. Chris P. out.
For more awesome content, like and subscribe now.